Hi everyone. In this video, we're going to see how to apply my rising points method in CrossLite. We'll cover both timed and continuous acquisition. Keep in mind that I designed this method specifically for software that lacks advanced tools for IR visualization and analysis, like CrossLite has. Before we get started, I highly recommend checking out my blog articles about the rising points method and watching the video courses on my YouTube channel. This will give you a solid foundation on the theoretical content and all the details regarding the method. In the meantime, let's prepare the interface as I've taught you, based on my personal workflow. In particular, expand the Sum IR window as much as possible. Next, disable autoscale by right-clicking with your mouse inside the Sum IR window. You will manage all of this by manually changing the numerical values of the vertical axis to find the best visualization of the rising point. This is the usual setup that is going to be measured and aligned, well known as the protagonist of all my recent videos. It is already known that the top is delayed by default by 20 milliseconds to allow for easy data reading, and that for a correct alignment, about 20.5 to 21 milliseconds are needed, plus a polarity inversion. We will now begin applying the method within timed acquisitions. Once the display is set, we need to choose the best acquisition method to avoid pre-ringing. At first, I suggest testing pink noise with no windowing, then with windowing, and finally with VTT4. You can also try log chirp 3T. Over time, the best trend will become clear to you. Remember, while efficient on the right side of the IR, some methods can distort the rising points. Always choose the best compromise for your setup. Let's decide to go with the first acquisition, for example. Now, let's activate the advanced cursors, red and blue. Using the blue cursor, let's place it on the top trace to mark the rising point of the top itself. Now, let's measure the subwoofer. For this as well, we need to evaluate which acquisition method is best for the specific circumstances. Keep in mind that you can perform these tests directly within the acquisition window, which makes the workflow much faster. In this case, for example, the acquisition with VTT4 seems to be the better choice. This is the subwoofer acquisition. Use the zoom tools to optimize your view. You can notice that, even if this is the best acquisition, the rising point looks deformed. Be careful not to confuse it with another small oscillation because of the previous gap. I have marked the starting point with the red cursor. Now, in the cursor readout section, I see a delta time of 2.7 milliseconds between the two cursors. This is the exact delay needed for the subwoofer to synchronize the two rising points. You can enter this value manually in the delay field of the subwoofer channel, or right-click to load it. And here are the two systems, synchronized. As you can see, and as we already know from previous videos, the only thing left to do is a polarity inversion. I want to emphasize again, be very careful not to confuse the oscillations caused by windowing operations, marked here with a symbol, with the actual oscillations of the signal waveform. Work done. We will now apply the method within Continue Acquisition. In this real-time option, we do everything directly from the acquisition window using continuous pink noise by selecting Impulse Response. In this case, I am not using any windowing, and the measurement is very clean. Unfortunately, in this specific window, it is not yet possible to zoom on the vertical axis, but the rising point remains clearly visible. In the Cursors section, let's activate the red and blue cursors. Place the first one on the rising point of the top. In this case, we are using the red cursor to mark it. Now, let's measure the subwoofer. In this case, I'm using a VTT4. I'll place the blue cursor on the rising point, and this way, I can read the delta time for the rising point alignments. Of course, you cannot be sample accurate here. Consider that low frequencies are like wobbly jelly in real world. Thanks for watching.